Hello everyone. In today's video, we will look at solving lead code problem number 5, longest palindromic substring. We will touch upon a brute force approach and then look at approach expand around centers which is accepted by lead code and in FANG interviews. Let's go through the question. Given a string S, return the longest palindromic substring in S. A string is palindrome if it reads the same backward and forward. Let's look at example 1 where input string is BABAD and output is BAB. This is because BAB is the longest palindromic substring in the input string. Another valid answer could be ABA. The length of BAB and ABA are same, so both of them are a valid answer. Both the strings when read forward and backward are the same. Now let's think about a naive solution that would come to a beginner's mind, which would be to find all the substrings of the input string. Let's say in this case the input string is BABAD. These are all the substrings of the input string. Next, for each substring, we'll check if they are a palindrome or not. We'll keep track of length of all the palindromic substrings. We'll pick the longest length substring which is a palindrome and return as output. In this case, BAB and ABA both are valid answer to be returned. Let's look at the code of the brute force solution. We will have a start and end pointer. All the characters between the start and end pointer will be considered as substring. For this substring, we check if it's a palindrome or not using this while loop. We do this by checking if character at left pointer and character at right pointer are equal. If the substring is palindrome, then the else block, which is tied to the while block, will be executed. In else block, if the current palindromic substring found has length greater than max length, then we update max string and max length values with that of the current palindromic substring. At the end, we return the max string. The total time complexity of the brute force solution is O of n cube because of 3 nested loops. The total space complexity of the brute force solution is O of n because of storing characters in the substring. Let's look at approach expand around centers to reduce time complexity from O of n cube to O of n square. The idea is to pick each index in the input string as the center and keep on expanding the left and right pointers till they are equal. Let's look at this solution by taking an example test case where S is BABAD. Let's say center is 0 and left and right pointers are initialized to the center. We can't expand the pointers because we will go out of bound. So the current palindrome is B, which becomes the longest substring so far. For same center equal to 0, now we want to track even length of palindromic substring. We do this by initializing left to center and right to left plus 1. The current substring is BA, which is not a palindrome, so we ignore the current substring and also ignore expanding the pointers. Next, we increment the center to pick index 1 as the center. The current substring is A, so now we will expand the left and the right pointers. After expanding the substring, the new palindromic substring is BAB. We can't expand the substring to the left because the left pointer is already at the left edge of the string. So for center 1, BAB is the longest substring of odd length. Because length of BAB is greater than the current longest substring so far, which is B. Hence, we update the value of longest substring to BAB. For same center equal to 1, we will check the even length palindromic substring. Because current substring AB is not palindrome, hence we ignore the current substring. We increment the center to pick index 2 as the center. We expand the left and the right pointer. After expanding the pointers, the new substring is ABA. We can't expand the left pointer and right pointer from this point because the substring formed will not be a palindrome. Hence, ABA is the longest palindromic substring with center 2. Because its length is equal to the current longest substring BAB, hence we ignore the current palindromic substring ABA. We increment the center to pick index 3 as the center. We can't expand the left and right pointer from this point because it would not form a palindromic substring. Hence, odd length longest palindromic substring with center 3 is A. We ignore it because its length is smaller than the longest substring so far, which is BAB. With the same center, we try to find the even length longest palindromic substring. Because the current substring AD is not a palindrome, hence we ignore the current substring. We increment the center to pick index 4 as the center. We can't expand the left and right pointer from this point because it would not form a palindromic substring. Hence, odd length longest palindromic substring with center 4 is D. We ignore it because its length is smaller than longest substring so far, which is BAB. We cannot find the even length substring with center 4 because right pointer would go out of bound of string. So we stop our search over here and the longest substring is BAB. Let's look at the code of the solution that we discussed. At line 3, we initialize the longest variable as empty substring. Then at line 5, we have a for loop which takes values from 0 to 2 times length of s minus 1. Then we initialize center to index divided by 2. Then we initialize the left and right pointers. Then we have a while loop to keep on expanding the substring around the center till characters at left and right index are the same. Then we have a if block where if length of current center substring is greater than longest substring so far, then we update the longest substring with current center substring. And line 18, we return the longest substring. Let's do a complexity analysis of our code. The time complexity analysis of our code is O of n square because of using two nested loops. The total space is O of n because of storing substring in longest variable. Thank you for watching this video. Stay tuned.